The other thing that you have to remember when drawing these cross sections is that you have to work accurately. For instance, use a very sharp tipped pencil, and you will have to use some mathematical compasses. You can use some triangles, and of course your very trusty old friend, if I can just get it out of this little box, your mathematical compass. Try to get a hold of a very good quality mathematical compass, because you don't just want the legs of this compass to move by itself. I'll show you, when I don't have glass on here, I'll show you a very easy way how to actually do some construction by using this if you've got an abacus at school. The thing though is, if you've got your map, okay, and here we've got our map, let's draw our map, you will want to project your strike lines down onto a profile, okay, where these black lines of course represent your contour height. So you will transpose where specific strike lines actually intersect the same contour on this profile line. Okay, now that is very easy, but the problem is, what the students always forget is that when you do this, okay, when you draw your profile, and I'm really exaggerating this now here, okay, there's 100 meters, 200 meters, 300 meters. When these lines, remember these lines represent points on the surface of the earth that has the same elevation above mean sea level. If they are not, first of all, parallel to each other, okay, you are lying, because it means that 100 meters are decreasing in elevation in that direction, 200 meters are increasing in elevation in that direction. It just cannot be, because elevation is always the same. That's why it's there. That's why there's contour lines there. So these lines must be parallel to each other, okay? That is very, very important. So the important place to start off with is, of course, to draw in your baseline on which you're going to work, and then by using, you know, either a good ruler like this, okay, or using your mathematical compass, which I will show you now, you will start off by drawing in the axis of this profile. And these lines have to start off by being at 90 degrees to each other. Then, of course, you will have to draw in on this profile these lines of same elevation, okay? And you have to make sure that they are equally spaced and that they are parallel to each other and at 90 degrees to this axis, which of course they will be. But you must also make sure that this distance here is the same as on your scale. So if you've got a scale here, which is, let's say this represents 500 meters, okay? But that distance there, when you measure it, is 30 millimeters. That tells you that 1 millimeter equals, okay, 6 millimeters equals 100 meters. So if these are contour intervals of 100 meters, this distance in between them should be 6 millimeters, okay? You cannot arbitrarily go and choose this, because if this scale is not the same as the scale of the map, you are introducing vertical exaggeration, which means that the angles which you will project on this will be incorrect, distances will be incorrect, and you basically sit with a geological cross-section that you cannot do anything with, because it is wrong. It is wrong. And I'm warning you now, when I mark maps in your final exam, especially on advanced field mapping course as well, and this case is not, you know, if this is not proper, it's going to be wrong, because your cross-section is just plain lying. Okay, so let's be very clear on this. Work with a sharp pencil. Take pride in your work. Do your constructions correctly. Why do we want to be so anal about doing the constructions correctly? Because there's already inherent faults built in all the way from the original mapping. Measuring data in the field, plotting it in the correct place on the map. Because as you can see over here already, that if the contour lines and the geology is not an exact representation of what they do in the field, your cross-section will not do the same. So there's already problems there. So everywhere, every step where you can actually minimize the import of additional errors into your data will help you to make a better cross-section. And it's not only important for now, it's important for your studies later on. If you want to do a master's or a PhD after this, it's important for your work. Okay? And your work reflects on who you are. If you don't take pride in your work, it means you've got no pride in yourself, and people will not respect you for that.